Hello everyone, now we will study about rain. In a group of quantitative data, there will be data with the largest value and data with the smallest value. So the definition of rain is the difference between the largest data and the smallest data. Rain is denoted by R. General formula of rain is R x maximum min x minimum. With R is rain, x maximum is smallest data value, and x minimum is greatest data value. For example, the final exam score for the C class statistics course is like this. The equation of this example is calculate the range of data. The solution, the first, we sorted the data from the smallest value to the largest value. From this data, we obtained score of x maximum is 19.8 and value of x minimum is 40. So the data range is R x maximum min x minimum. Range is 58.
The first is about variance. In statistics, variance is used to measure the distribution of data. It's measure of how far each value in the dataset deviates from the mean. As we see in the picture, we can calculate the distance for each data by the drag xi with x bar. The distance left the mean is always negative, and the right is always positive. One thing that's important to notice is that the distance must be higher than 0, so we must square the deviation. Variance is divided into two types: population variance and sample variance. Population data make 100% sure of the measure we are calculating, and a sample is an approximation of the population parameter. Population variance represented by sigma square, which is mean the sum of square difference between the observed value and the population mean divides by the total number of observation. Sample variance represented by S squared, which is mean the sum of square difference between observed sample value and the sample mean, divided by the number of sample observation minus 1. From the two formulas above, why does the divisor for the sample different from the population? To understand why dividing by n underestimates the population variance, we'll start with a few simple examples and we'll divide into the math and prove it. For example, we have a population of 5 observations: 1, 2, 3, 4, and 5. Let's find its variance. The first step, we start by calculating the mean. 1 plus 2 plus 3 plus 4 plus 5 divided by the total number of observation is 5. And the value of mean is 3. Then, we apply the formula which we just discussed. After we calculate with the formulas, the value of variance is 2. So, the population variance of the dataset is 2. But what about the sample variance? This would only be suitable if we were told that these 5 observations were a sample drawn from a population. So, let's imagine that case. The sample mean is once again 3. The numerator is the same, but the denominator is going to be 4 instead of 5. Why is the sample variance bigger than the population variance? In the first case, we know the population. That is, we had all the data and we calculate the variance. In the second case, we were told that 1, 2, 3, 4, and 5 was a sample, drawn from a bigger population. Now, imagine that the population of the sample were the following 10 numbers: 1, 1, 1, 2, 3, 4, 5, 5, 5, and 5. Clearly the numbers are the same, but there is a concentration around the two extremes of the dataset is 1 and 5. After we calculate, the value of the mean is 3.2 and the value of variance is 2.96. So, the sample variance has rightfully corrected upwards in order to reflect the higher potential variability. This is the reason why there are different formulas for sample and population. Hello everyone, in this discussion, we are going to practice calculating the mean deviation for a given dataset. Mean deviation is the average distance of all of the elements in a dataset from the mean of the same dataset. So basically, we are trying to figure out on average how far each piece of information or each piece of data in your dataset is away from the mean of your dataset. Let's use this example to calculate the mean deviation. The following dataset represent the income of 10 residents from 2 housing complexes. Step 1 will always be to find the mean of the given dataset. To find the mean of any dataset, you have to add up all of your elements together and divide it by the total number value. The sum of 10 elements complex A and complex B is the same, that is 61. And we divide that by 10. To figure out what the mean value is, we would say the mean of the income of 2 complex was 6.1. After you have figured out what the mean value of your dataset is, you have to distance that each element in your dataset is away from the mean if it were on a number line. So basically, you are going to subtract each element with the mean and use the absolute value because the distance is always positive. So we have to subtract each element from our dataset from the mean value of our dataset. After you have subtract each element in your dataset from the mean of the dataset, you have to remember to use absolute value of each difference. For example, even though 2 minus 6.1 is negative 4.1, we would say that the distance between 2 and 6.1 on a number line is 4.1 regardless of direction. So always make sure to express the difference of each element from the mean as a positive number. So next, we are going to add thus 10 distance that we came up with and divide by 10 because we have 10 numbers that we add it all together. For complex A, the mean deviation equals 3.1. We can say that the values in the dataset on the mean are a distance of 3.1 away from the mean of 6.1. While the mean deviation for complex B equals 0.94. We can say that the values in the dataset of the mean are a distance of 0.94 away from the mean of 6.1. From the table above, it is found that in complex A there is an imbalance of income for residents which is quite largely compared to complex B, with the income of residents in complex B which tend to be the same. The last of this discussion is conclusion. The first, to find the mean deviation on dataset, you can use a formula SR equals sigma of the distance between each data and the mean and dividing by total number values. With SR is mean deviation, Xi is element of data, X bar is mean, N is total number value, vertical bar is absolute value, and basically to ignore minus signs. Second conclusion, that the mean deviation indicates how spread out your dataset is. The third conclusion is a larger mean deviation indicates a dataset that is more spread out in relation to the mean, while a small mean deviation would indicate data that is less spread out and located closer to the mean.
Okay, next standard definition and quartile rings. Standard definition is a statistical value that is used to determine how the data is distributed in a sample and how close the individual data points are to the means or reference value of the sample. Standard definition formula is equal to square root 1 divided by n minus 1 sigma xe minus x bar squared. Information is standard definition, xe is data value, x bar is reference value, and is lot of data. Before using the formula, it is good to know where the origin of the formula is so that we can know the philosophy of calculation and it is. First, we first word the intellectual standard definition formula as follows. Is equal to square root 1 divided by n minus 1 sigma xe minus x bar squared. Next, understand that a minus b squared equal to a squared minus 2ab squared plus b squared, so that s equal to square root 1 divided by n minus 1 sigma xe squared minus 2 xe squared x bar plus x bar squared. By using the terms of sigma notation for the formula above can be described as follows. A is equal to square root 1 divided by n minus 1 sigma xe squared minus 2 x bar sigma xe plus n x bar 2 x is equal to square root 1 divided by n minus 1 sigma xe squared minus 2 n x bar squared plus n x bar squared, so that is equal to square root 1 divided by n minus 1 sigma xe minus n x bar squared. Standard definition function. Usually that standard definition is asked by statisticians or the people working in the world to find out if the data sample takes respond the entire population, because once the range data for a population is very difficult to do. Thus, it is necessary to assume that sample that corresponds to the entire population makes it hard to conduct research or attacks. Illustration is someone wants to know the weight of a boy aged 10 years in a school. That what needs to be done is to find out the weight of some people and calculation of range and standard definition for this calculation will know that value that can respond to the entire population. How to calculation the standard definition of a single data. First, log for the range value first x bar equal to sigma x divided by L. Second, find a single standard deviation. X equal to square root 1 divided by m minus 1 sigma xe minus x bar squared. Example of question and this question during term suspension consecutive semester repetition or at his beloved campus in London, Jonathan scored 92, 79, 86, 80, 75, 187, 93, 90, and 88. What is the standard definition of the test score? Answer: tables. From the calculation of the standard definition formula, the result are options for the calculation. We can see the tables above. So that is equal to sigma x equal to square root 1 divided by L minus 1 sigma xe minus x bar squared is equal to square root 1 means n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10 minus 1, 4, 5, 6.9. Quartile range. Quartile range is still occurs with a single quartile and a group quartile on each side. Definite formula. The quartile range formula is as follows: Jk equal to 1 divided by 2 k3 means K1 information Jk is quartile range, K1 is reference quartile or first quartile, K3 is copper quartile or third quartile. Example equation, and this question determines the quartile derivation from the table below. Interval frequency or Fe, cumulative frequency or Fk. Answer: to determine the quartile duration, we must first find K1, K2, K3 with the group quartile formulas because the problem is tables with the group quartile formula as follows: P equal to TBP plus P divided by 4 and minus Fk divided by FEG. Location K1 equal to 1 divided by 4 K1 equal to 52. Location K2. K2 equal to 65.5. Location K3. K3 equal to 82, so quartile rings jika equal to 1 divided to K3 minus K1 jika equal to 1 divided to 82 minus 52 equal 15.